This video is made for the Introduction to Electromagnetic Field Theory, EMT STE 2523. And in this video, I'm going to cover on the vector analysis. The subtopic for the vector analysis that I'm going to cover in this video is basic law of vector algebra, vector addition and subtraction, position and distance vectors, and the last one, vector multiplication. This is a vector. Let's say we name this vector as vector A, and this is the way we write a vector, either by bold the letter or put a line on the letter. The vector has two components. Okay, the first one is magnitude. A magnitude indicates the length or size of a vector. And this is how we write a magnitude of a vector. The second component is direction. Normally, we write a lowercase with a hat to show a direction of a vector. This A hat is known as a unit vector. Unit vector has a magnitude of 1 in all axes. Okay, let's say we have a vector in this green line, and this vector is represented using this equation. So what does this equation mean? This equation shows that we are scaling the magnitude of vector A from the unit vector. So in this case, we scale 1.5 in the x direction, 0.7 in the y direction, and 0.5 in the z direction. Vector addition. A summation of two vectors will give another vector. In this case, I name it as vector C. We can write either A plus B or B plus A. Graphically, vector addition can be obtained in two ways known as parallelogram rule and head-to-tail rule. Okay, follow the parallelogram rule. We draw A and B from the same point and we keep the magnitudes and direction unchanged. And the vector C is the diagonal of the parallelogram found by vector A and vector B. With the head-to-tail rule, we may add either vector A to vector B or vector B to vector A. In this example, I add B to A. So, it is positioned that the B tail starts at the tip of A. And another vector coming from the addition A and B is vector C. And the vector C starts from the tail of A and ends at the tip of B. Okay, this is how we present a rectangular coordinate system for this vector addition. As you can see here, in the unit vector X, we add the magnitude of A and B in the X direction. In the unit vector Y, we add the magnitude of A in the direction of Y and magnitude of B as also in the direction of Y. And in the unit vector Z, we add the magnitude of A in the Z direction and the magnitude of B in the Z direction. Vector subtraction. Let's say we have a vector B. Okay, then we have minus vector B. This minus vector B is also a vector B. However, it is in the opposite direction. Thus, the magnitude of minus vector B is equal to the vector B. Due to this, we can define vector subtraction. Vector A minus vector B. And cos or it gives vector D. And this is how we represent the vector subtraction in a rectangular coordinate system. Now I'm going to explain a position vector and distance vector. A position vector is a vector from origin to a point. In this example, we have R1 as a position vector start from origin to P1. And we have another position vector, R2, start from origin to P2. Okay, the distance vector, R12, is the displacement from P1 and P2. We can calculate the distance vector by subtract the starting point from the end point. And this is the equation for the distance vector. Okay, now I'm going to explain on the vector multiplication. We have two types of vector multiplication. The first one is scalar or dot product, so A dot B, and the second one is vector or cross product, A cross B. Okay. Let's take a look at this illustration. Okay, where we project A along vector B. Thus, we get A cos theta, and this gives A dot B is equal B times A cos theta. We arrange it and we get A B cos theta. In other words, a dot product is a length of A times with the length of B, then multiply with cosine angle between A and B. If A dot B is equal to 0, the vector is said to be perpendicular. This is because cos 90 degree is equal to 0. A cross product between A and B give another vector A, B sine theta AB in the direction of N. Let's take a look at this illustration where we have vector A and vector B. Thus, the theta is in this angle. It gives another new vector in the direction N. The magnitude of this cross product is equal to the area of this parallelogram. And this cross product follow right hand rule. And as you can see here, this new vector or the n hat is a perpendicular to A and B, and it known as a unit vector normal. So let's take a look at this right hand rule for the cross product. Okay, let's say this is for the A direction and this is for the B direction. Thus, the product will be here. So that's all for this video. Thank you.